Alright, so we're going to learn a new form of our quadratic equations. It's called descriptive form or vertex form. Okay, so right here, descriptive form, vertex form, highlight that please. Okay, when an equation is written in descriptive form, we can identify as anticipated pretty easily we can identify the vertex and then some other characteristics of the graph. So when this is vertex form, so the one that we did before, right, was standard form, and that was when we had ax squared plus bx plus c, standard form, ax squared plus bx plus c. Vertex form or descriptive form is a and then the quantity x minus h squared plus k. So our line of symmetry will be x equals whatever the opposite sign of that h is. Okay, so if h if it says x minus 2, then the h would be 2, right? If it says x plus 4, then the h would be negative 4. So whatever this h value is, the sign changes, and that is the x coordinate of our vertex. And then whatever the k is, the sign stays the same, and that's the y coordinate of our vertex. The a tells us, as it did before, whether we open up or down, whether it's wide or narrow. The h, whatever the h is going to move our graph left to right. So if it says x minus 2, then we're going to go 2 to the right, again, because that sign is opposite. So we got to remember here, we can make a little note, opposite sign. But the k stays the same. K moves it up or down, h moves it left to right. Because the h is the x coordinate of our vertex, and x moves us left to right. The k is the y coordinate, moves us up or down. So let's see some in practice. You can use some of these examples to practice. Okay, so we're going to graph this function. We're going to identify these characteristics of it, and then we'll graph from there. Okay, so looking at this form, it has this quantity squared. So this is vertex form because of the parentheses squared. Okay, so this 4 here is our h, but we want to remember that the sign is going to change. So our h here is negative 4, and then our k, the sign stays the same, so our k is negative 2. Our a value is 1. That's just our home base a there. So our vertex is h comma k. So whatever the opposite sign is with our x, comma, the same sign outside our parentheses. Our line of symmetry is always the x coordinate of our vertex. This graph would be facing up because of our a value here. So this has a minimum. The y-intercept is whatever y is when x is 0. So we're going to plug 0 in for x and evaluate it to get our y value. 0 plus 4 squared is 16, and 16 minus 2 is 14. So our y-intercept is 0, 14. Oops. The domain, as normal, is all reals, and then the range is whatever, so we're facing up, so we're going to be all the y values greater than or equal to whatever the y coordinate of our vertex is, negative 2. Okay, so let's put all these points that we've identified 2 points there we can put on our graph. Negative 4, 1, 2, 3, 4, negative 2. And then we can put our y-intercept. Our y-intercept actually, I guess, is off the graph, so let's not use that. So we just need another point that's next to our vertex. So our vertex is at negative 4, negative 2. So I'm just going to use negative 3 and use that x value. Make a little mini xy table, okay? I'm going to use negative 3 and plug it into my function to get my y value. So negative 3 plus 4 squared minus 2 would be negative 3 plus 4 is 1, squared minus 2 would be 1 minus 2, or negative 1. So that point that I just evaluated there is negative 3. When x is negative 3, y is negative 1. So I'm going to put that on my graph, negative 3, negative 1. I'm going to reflect that over my line of symmetry here, which goes through my vertex. And then I'm going to draw my parabola up through those points. I could even put another one, over 1, up 1, 2, 3, right? Because my A value is 1. My pattern is going to be my home base pattern, growing 1, 3, 5, etc. Okay, a lot of different methods that we can use to graph this here. So figure out what you like best in terms of graphing, and then try to just be consistent. Okay, so I'll probably always show you multiple ways and talk about multiple ways, and then you just decide which one you like best. You can make a table, you can use our pattern, you can use the y-intercept to reflect it over the line of symmetry. Okay, figure out what you like. Stick with that. All right, we're going to graph another one. So again, identifying the vertex, this is our h, and it's going to be the opposite sign, so that's the x value of our vertex. So the x value of our vertex is 3, and then the y value is here, and that sign doesn't change, that sign stays the same. So 3, 4 is our vertex. So I'm going to go ahead and put that on my graph. The line of symmetry is always x equals whatever the x coordinate of my vertex is. -2 is my A value. So -2 means that my graph is facing down, and that means that I have a maximum. I'm going to put my domain, all reals. My range is going to be y. Because my graph is facing down, I'm going to be all the y values less than or equal to the y value of my vertex, 4. And then my y-intercept I find by plugging 0 in for x. So I'm going to evaluate this. 0 minus 3 is -3 squared. -3 squared is 9 times -2. 9 times -2 is -18. Plus 4 is -14. So my y-intercept is 0, -14. And then again, I think that's off my graph here. So I'm going to go ahead and I'm going to use my pattern this time. So my home base pattern is 1, 3, 5, 7. But my A value is -2, so I'm going to take this pattern and I'm going to multiply it by -2. So I'm going to move instead at -2, -6, -10, etc. So from my vertex point, I'm going to go over 1 and then I'm going to go down 1, 2. I'm going to reflect that over here. I'm going to go over 1 and then down 1, 2, 3, 4, 5, 6. And reflect that over here. Okay, and then there is my function. Okay, so again, you can use the pattern. You could make an XY table. So my vertex is at 3, 4, so I need to figure out maybe what the 2 point is, right? When x is 2, what is y? So you'd plug 2 into your function and evaluate it. And you should get that y is 2. Okay, so however way you want to do it. But there's a lot of graphing, and then next year in Math 3, you're going to be graphing a lot again. So make sure if you have questions that you're writing them down and asking in class tomorrow. All right, now we get into some word problems. We're going to see a lot of word problems this unit as well, because there's a lot of real-world application of parabolas. You think of the flight of a ball. If you throw a ball to somebody, it goes, you know, you're standing here, you throw the ball, it goes up and then comes back down. That path of the ball is a parabola. So gravity gives every path of flight a parabolic shape. So that's kind of cool. So we're going to graph a lot of things as quadratic functions. Okay, a lot of real world scenarios. So example 3. Word problems, we want to figure out what information we need and how it's going to show up in our problems. So an apple tree yields 275 apples per tree when 25 trees are planted per acre. So I would encourage you to always circle numbers whenever they show up in word problems. For each additional tree planted per acre, the yield of the tree decreases by 5 apples. So each additional tree yield decreases by 5 apples. So I'm thinking this 5 here is going to end up being a -5 because we're decreasing. And then it'll probably show up as like a slope or being multiplied by something. If the function y of x equals -5 times x minus 40 squared plus 8,000, so I'm going to rewrite that equation down here. Y of x, again, that's just function notation. Y of x equals -5 times x minus 40 squared plus 8,000. This is my function, where x represents the number of trees per acre. I'm going to underline this. Seems like important information. Maybe underline or highlight or box. Y of x represents the yield of the total number of apples per acre. Then how many apples per acre can be expected if 30 trees are planted per acre? How many trees should be planted per acre to maximize the yield of apples? And what is the expected maximum yield of apples per acre? So there's 3 different questions that I've got to answer there. I want to take note of that. 1, 2, 3. I should have 3 different answers. Okay. So first thing first is we know if this is this is a quadratic function, right? It's got a negative a value. So I'm thinking if I were to graph my apples, my yield per apples per acre, yield of apples per acre, then my graph would go something like this, right? I know that one of the questions is asking me about a maximum, right? How many trees should be planted per acre to maximize the yield of apples? So the number of trees per acre, they told me that x represents the number of trees per acre. So on my x-axis, this would be the number of trees, and y represents the number of apples. They told me that in the problem. Okay, so if they're asking me in question 2, how many trees should be planted to maximize the yield of apples, that means they're asking me for the x-coordinate of my vertex. Because if I look at my vertex, that is the maximum, right? So this is the x-coordinate of my vertex. That would be here, right? X comma y. X would be the number of trees, y would be the number of apples. So my second question is asking me for the x-coordinate of my vertex. And my the third question, expected yield of apples per acre, that's asking me for the y-coordinate of my vertex. So I can answer those questions right from my equation because this is an equation that is in vertex form. So my vertex is here, opposite sign there, right? So positive 40, comma, and then my k value is my y-coordinate, 8,000. So this is saying that if I had 40 trees per acre, and that's what they're asking me in question 2. So how many trees should be planted to maximize the yield of apples? If I plant 40 trees per acre, then I can expect a yield of 8,000 apples. And in context, so I don't know if there's any farmers or if you guys have any relatives who have farms, but if you plant too many plants in too small of a space, then they'll take nutrients and such from each other and they won't grow as well. So that's the idea here, right? We want to plant more so that we get more, but at some point we plant too many too close together. So we've answered question 2 and question 3. Those are based on the maximum, keyword maximize, right? Maximum yield. Okay, and then the first question was how many apples per acre could be expected if 30 trees are planted? So that gives us this 30. We know that x stands for number of trees. So to answer question 1, all we have to do is plug 30 in to our equation and evaluate it. So we go, if we planted 30 trees per acre, that would be -5 times 30 minus 40 squared plus 8,000. 30 minus 40 is -10. We're going to square it and add it and multiply it by -5 and then add it to 8,000. Okay, y of 30 equals, negative 10 squared is 100, times negative 5 is negative 500, plus 8,000. So if we plant 30 trees per acre, we can expect a yield of 7,500 apples. Okay, so what we'll want to recognize is that in a lot of these word problems, they're going to be asking for the same thing. Most of the time, they're going to be asking you to evaluate a certain number, so you'll plug that number into the equation, and then they'll also usually ask you about the minimum or maximum. So you got to identify the vertex, and when we're in vertex form, it's easy because those numbers are right in the equation. So we'll do one more here. We'll do the golf ball. Okay, same idea we talked about. You chip a ball in the air, it's going to go up and then come back down. Okay, so they give us the equation here. There's some information in the problem, but they give us this equation. H, the height of the ball at any given time, will be equal to negative 16 times the time minus 2 squared plus 64. And then they ask us 3 questions. Again, they ask us how long will it take the ball to reach the maximum height? Okay, that's going to be so if we're thinking of a graph, right, the ball goes up and then comes back down. Okay, time is represented on your x-axis, height is represented on your y-axis. So if we want to know how long it will take to get to its maximum height, then we're looking for the x-coordinate of the vertex. And if we're looking for its maximum height, then we're looking for the y-coordinate of the vertex. Y-coordinate, how long will it take? X-coordinate. Again, they're almost always going to ask you about the vertex. And they ask you how high is the ball at 4 seconds, so they just want us to plug 4 in for t. Okay, so can we identify what the vertex is from this equation? It's in vertex form, so the 2 here represents our h, and it's the opposite sign of what's in there. And then the 64 represents our k, so that's the same sign. So at 2 seconds, the ball is 64 feet high. So those answer our first 2 questions. How long will it take the ball to reach its maximum height? 2 seconds. And then after that 2 seconds, it starts falling. And the maximum height the ball reaches is 64 feet. 64 feet. Then the third question asks how high is the ball at 4 seconds. So we're going to take the 4, plug it in for t. So the height of the ball at 4 seconds would be equal to negative 16 times 4 minus 2 squared plus 64. 4 minus 2 squared is 2 squared. And 2 squared is 4 times negative 16. 4 times negative 16 is negative 64. If we add that to positive 64, we get that the height of the ball at 4 seconds is 0. Hey, what does that mean? It means the ball at 4 seconds is back on the ground. Started on the ground, got hit into the air, fell back to the ground. So the height of the ball at 4 seconds is 0 feet. Okay, I would like you all to see if you can answer example 5. Okay, I want to see at least some guesses, all right, some thought to put into that. If you don't know how to answer it, then I'd like you to write a question because you need some clarification on something. All right.